Oh yes.
Next semester is the last time I can teach you, so I gotta soak it all in.
That's
She's in like 10:30 class, so I can't. I'm not a bio teacher or whatever, so I can't teach her anything other than chemistry. So that's the last time she'll be my student. Unless they ask me to teach biology, in which case,
yes, please.
God help us all.
Go to the biology unit,
Yeah, it's like I know all this stuff. It's just, well, the bio stuff and science is quite different. So yeah, there's no application. Other than osmosis and diffusion and stuff, it's all just.
Oh, you think so?
Yeah.
For copper and the 3.
Nitrate.
But is it also for so isn't it what it's located over? Same molar masses is how many gets
Yeah, but like
87. Because it won't allow me to.
And then just now? No, it would say metal. It would say metal. On top of 2 units. Same thing.
When you do the molar mass, taking out the 3 and the 2.
Wait, what? Why is it like this?
I had it.
what about the nitrate?
I wasn't even finished.
Yep, that's fine. Yep, but one of those needs to be precipitate, right?
Yeah. So now I have to do what I want, which I want this. So I just feel like I've calculated the whole
Yes or no, did everybody get this equation? Perfect. So we're looking for the mass of strontium sulfate, or our precipitate, if we are given 2 grams of strontium nitrate. Can you go straight from our molar ratio, right? The molar ratio is the thing that converts to 2. Can you go straight from the molar ratio to a mass?
No.
Not really. So you need more mass. Yes, sorry, they're just right here.
Thank you. Okay, I think. Mr. Wilson,
Yeah.
I think I got it.
I mean, that makes sense to me. I can't remember the exact answer, I guess. $279. Ma'am, I'm scared. Get 150 milliliter beaker. Go to electronic balance and measure 2.56 grams of copper sulfate. Our favorite thing. Measure. I actually like measuring them. Dissolve in 50 milliliters. Okay, I'm gonna stop you. I am totally 100% gonna stop you. So, I don't know, you should be able to figure out what mass you got. It's gonna be like relatively close to the 2 gram mark, right? It's not, I mean, it's okay, don't worry about it. So you should be able to calculate, that's a stoichiometry problem that I expect you to be able to get. Now what I want to do is I want to start going over the actual lab of what you want to do. This is, don't let the procedure kind of get in the way of how phenomenally simple this lab actually is. Remember when we were talking about the net ionic equations? Remember when we were talking about the net ionic equations and we had in one beaker we had solution A, and in another beaker we had solution B, and all we had to do was pour them together, right? So we just poured this together into this, and then we ended up getting a solution with a precipitate at the bottom. That's, in a nutshell, that's all we're doing. How much strontium nitrate do we have to weigh out at the beginning of the lab? 2 grams, and then dissolve it in some water. How much copper 2 sulfate do we have to weigh out at the beginning of the lab? 2.56 grams, and dissolve it in some water. And then what do you got to do with those 2 solutions? You gotta mix them together. Now, we're gonna start talking about something called quantitative technique. And what quantitative technique is that if I've got two different solutions, okay, I'm not gonna create a precipitate, but it's totally fine, don't worry about it. Let's say I take one beaker, I take one solution, and I add it to another, okay? So I've got this solution, I've got this solution, solution A and solution B, and I want to take one and dump it in the other. Perfect, no problem. Maybe I get a precipitate, maybe I don't. There's a little bit of a problem with me just dumping from one beaker to another. Does anybody know what the problem is that I have to kind of deal with right now? There's leftover stuff, isn't there? In this beaker, I don't know if you can tell, but there's solution left over. And that might not be that big of a deal to you right now. You might not think that that's that big of a deal. But any leftover stuff in here, I want to transfer into that other solution. I want to quantitatively transfer it. Quantitatively means all of it. And so what I would do in the beaker that I dumped out of, I would rinse it with distilled water, and I would make sure I got all of the remaining stuff, and I would rinse it again. Make sure I got all the remaining stuff. Is that okay? And then you're going to have some sort of a precipitate in here in your final solution, right? And all you have to do is try and filter it out. So in here, I've got, I'm going to break something, but whatever. I've got just filter paper inside a funnel, and then I've got a beaker on the bottom. We care about what? Do we care about the solid in the filter paper, or do we care about the liquid that's coming out? We care about the solid, we care about the precipitate, right? And so what you would do is you would just dump your solution. Don't fill it up too much, right? Maybe you have to dump a little bit at a time and let it drain, and then go back and dump a little bit more and let it drain. That's totally fine. If that's what you have to do, then that's what you have to do. But our filter paper is going to capture our precipitate. And we're going to leave it to dry overnight. Because if I just filter it and then I walk over the balance and I weigh the precipitate, is it going to be way too high? Is the mass going to be way too high or way too low?
Way too high.
Way too high, like astronomically high. Why? Well,
Because of gas gravity.
Well, what?
It's like wet with the water touch.
There's extra mass in there that needs to evaporate still, right? Yeah, and so I would go back and I would just dissolve it, keep going back and keep dissolving it. Now, let me be very clear, the more water you use to dissolve all your substances, the more you have to wait and let it filter, okay? So the more water you use, the longer you're gonna have to wait and let it filter, but whatever, that's fine.
How long should this take us?
The actual lab should take you like 15 minutes, not even. And then you're gonna set it up to filter. Is that okay? And then, so we're gonna set, what I would like you to do is, like, you're gonna have all of your own apparatuses, all of these apparatuses to set filter or whatever, and then we're gonna have to figure out, my job is to figure out a place for you to actually store them, to like filter, because, I don't know, we'll talk about it later. Like, do you feel comfortable doing this? Yeah, so dissolve the copper 2 sulfate in 50 milliliters of water, use another beaker, dissolve that in water, right? While stirring, slowly combine the two solutions. So pour one into the other, record your observations. Measure and record the mass of a piece of filter paper. So the filter paper, have you ever used filter paper before in a chemistry lab?
No.
I want to say most of us, this is our first time. The typical way for getting a piece of filter paper, it's just a circular piece of filter paper. So it's going to be pretty hard for you to take this and turn it into a funnel. You know what I mean? Put it into a funnel. What? Yeah, so what I want you to do, you're just going to fold it in half. And then while it's folded in half, you're going to fold it in half again. And so what you can do is there's a couple little pockets here, and you can just open up one of the pockets, and it forms the same shape as the cone would. And then I would stick this, the first thing I would do, I'd stick it into your funnel, but as soon as it sticks into the funnel, it's going to want to pop back into its original shape. So just take some water and wet the sides of it, stick it in there, wet the sides of it, and the water will like glue the filter paper to the inside of the funnel. It's pretty easy. It's not that big of a deal. Let me know if you want any help with that. Moisten the filter paper, place it in the funnel, filter the mixture, use a wash bottle to rinse the beaker into the funnel, right? Quantitatively transfer it into the funnel. And when the filtration is complete, place the filter paper on 2 layers of paper towel, and then we'll have it drying. Hopefully it'll finish filtering by the end of class, and we can just have it drying in here. So I expect every single person to be back into the class at about 1:35. Is that okay? It's a phenomenally easy lab to do, so whatever, we can go ahead and do this. You need glasses. Glasses are fine. You don't need aprons if you don't want them. Yep.
Oh, it's been. Why don't we calculate it when we come back?
Yeah, because I get 3 point something.
Okay. Can I get your attention, please? So, as that stuff is filtering, I will totally monitor it over the next, 24 hours, kind of just in general monitoring it. And then I'll make sure that these solutions all get filtered. And then once they get filtered, I will put them out onto the labeled paper towel. Tomorrow I'm not here, so you're going to come in. The first thing you're going to do is you're going to weigh your filter paper plus the stuff. Okay. Now the idea is you've got the mass of the filter paper. Let's say that was 1 gram, right? Just to be really easy about it. Then we would have the mass of the filter plus the precipitate. Okay, let's say that was 2.5 grams. So I'm curious, quick math, does anybody know what the mass of the precipitate would be in this example? 1.5 grams, right? You take the mass of both of them, subtract the filter. When you subtract the mass of the filter, you just get the precipitate. So the mass of the precipitate is 1.5 grams. Now that's if you measured the mass of the filter paper. If you didn't measure the mass of the filter paper, what you would have to do is you would have to take your filter paper and scrape it off and then measure it into a beaker or something like that. Does that make sense? That's way less fun, but it's just kind of the way it goes. What I want, we got 4 or 5 minutes left. I want us to do this mole calculation review. There's only like 5 questions on here, and the solids one should be really, really easy for us to do because we've already kind of done it. I want to focus on these 2. We've done gravimetric stoichiometry. Gravimetric stoichiometry is getting a solid from a solid So masses to masses, that kind of thing. We're going to start talking about on Monday, we're going to talk about gas stoichiometry. And I just want to bring you back, I want to kind of pull you back to a couple months ago when we were talking about gases. Determine the chemical amount. What does chemical amount mean? Moles, right? Of hydrogen gas when 7.6 liters of gas is held in a container at 22 degrees Celsius at a pressure of 125 kilopascals. Do you have to convert what? Yes. You're going to have to convert to Celsius. Do you see moles in here anywhere? No. Okay, let me bring you back to the gases unit.
The moles per liter.
Are we, it's not moles per liter. Are we talking about a change in something? Do you see T1, T2, P1, P2, V1, V2? No, so you have to use what, Aaliyah? You have to use the constant, 8.314 liter kilopascals over mole Kelvin. Can you get moles from this?
Yes.
What do you have to cancel out in order to get moles? You have to cancel out Kelvin, liters, and kilopascals. Do you have all three of those things? Kind of.
Yes.
Remember, you got to turn degrees into Kelvin. I just only want you to do these two questions. Do these two questions. Please get them done for Monday. It is not for homework. We are not marking it in class, but I want you to remind yourself how to do this, okay? Tomorrow I'm going to give you time to work on, you and Mr. Brown are going to get time to work on measuring the masses of this stuff, working on some problems, okay? Did I give you your major assignments?
Yeah.
Did I give you your review booklet?
Yes.
Yeah, so you've got some stuff you could work on, right? But I'll give you more things to work on as well. Tomorrow's just going to be, let's make sure we understand stoichiometry. That's what tomorrow is about. Are we good?
Yes.
Okay, the bell's going to go in about 30 seconds. So you can try this question, but get these two done for Monday, please. And I will be in charge of supervising this.
It's like binocular.
You're more quiet than me.
Have a good weekend. Like, you have school tomorrow, but have a good weekend.
You too.
Thanks.
What she wants us to communicate
Best Buy's up there. The funnel. This piece of equipment is called a funnel. Whatever that one is. Okay. Yeah.
Thank you.
Yeah, no problem. Here, I'll take it. I haven't been able to fit. I don't know if I'm going to be able to fix it. So I'll try one more thing. Thank you. I'll try one more thing, but we'll see. Yep, no problem.
Also, I worked on all the notes that were in here, so did you want this back?
No, that was yours to do with as you please.
I
Yeah.
wasn't too sure if you wanted it back or not, because
Totally.
someone else. So I don't think.
No, it's all good. Yeah.
Have a good weekend.
Have a good weekend.
Thank you.
Mr. Walton, my friend.
How are you, Giovanni? I'm doing okay, man.
Giovanni.
Giovanni, my friend, how's it going? Not bad.
It's bad.
Hello, this is Graham. Hello. Okay. Thank you. Bye.